All right, now we've got the graph y equals x squared take 2x take 3. We need to sketch it. We're going to go through the normal steps. And yes, I'm going to do the normal steps one last time, but you should be remembering this by now. So first we need to do concave. So first of all, we normally have y equals ax squared plus bx plus c. In this one we've got y equals x squared take 2x, take 3. So a is 1, b is negative 2, c is negative 3. Concave. Well, this one's concave up because a is positive. Okay, next step, y-intercept. So we let x equal 0. And you guys are getting really good at making that equal 0. So we've got y equals 0 squared, take 2 times 0, take 3. You don't need to write that out. You could have seen that that's negative 3 straight away. X-intercept, let y equal 0. Yep. So we've got 0 equals x squared, take 2x, take 3. Now, you either factorise or quadratic formula. X equals minus b plus minus the square root of b squared take 4ac all over 2a. I'm not going to do that. I'm going to factorise. So, two things that multiply to give negative 3, that add to give negative 2. X take 3, x plus 1. So x equals 3 and x equals minus 1. You would have gotten the same answer both ways. Okay, next step. Axis of symmetry. You can do halfway between x's. Or x equals minus b over 2a. I'm going to do halfway between the x's. X equals minus 1 plus 3 over 2, negative 2 over 2, 1. Okay, the y-coordinate, sub in x. So we've got y equals 1 squared, take 2 times 1, take 3. So y equals negative 4. And now we sketch. We're not going to be brilliantly accurate. We're going to mark in our y-intercept, negative 3, x-intercepts, negative 1, positive 3, x-axis of symmetry, y-coordinate of the axis of symmetry, and it's going to go, if I can draw, looks like that. That's it being sketched. So, now we're up to 3b. And we've been asked to do a whole bunch of things to this. Oh, sorry. So I'm going to cheat. I'm going to copy it. Get rid of all the extra rubbish. So I'm going to do it thicker so it looks better. Okay. So that's y equals x squared take 2x take 3. First thing they've asked for us is reflected in the y-axis. So if it's in the y-axis, I want to reflect it along the middle line, along there. So this point wants to be here. This point wants to be here. Let me get rid of those. So it ends up, its turning point is going to be here instead. Its intercepts are going to be here and here instead. So I'm just swapping the x coordinates of anything. Reflected in y, swap x coordinates. So I'm going to make them negative. So for example, the turning point was at +1, I'm now making it at -1. The x-intercepts were at -1, +3, well I'm making them +1, -3. Does that make sense? Well, I hope so. So this time, it looks like that. So x-intercepts +1 and -3, axis of symmetry, -1 instead of +1. Okay, now they want it reflected in the x-axis. So that was reflected in the y-axis, and I might just move all of this up here. So for number 2, reflected in x, swap y coordinates. So I'm making anything that's positive, negative, and the other way around. So the y-intercept is going to be, instead of being at -3, it's going to be at +3, and the y-coord of the vertex, instead of at -4, it's going to be at +4. And it's going to be concave down instead of up. So I've still got the same x-intercepts. My y-intercept is now +3. My axis of symmetry is now at +4, but it's still +1. So let me get rid of all those. They make it really messy. So now, so it's going to turn there. So now it's going to go down like that. And that. Okay. Now let's see when it says in both. So I'm essentially going to swap all of it. So I'm going to swap the x coordinates. I'm going to swap the y coordinates. I'm going to do all of this with the x-intercepts. But it's not going to be concave up. I'm going to do all of this with the y-intercepts. Which means my x-intercepts, +1, -3. Y-intercept, +3. Axis of symmetry, -1. Y-coordinate, +4. We get rid of those. So I know it's turning here. And that's that.